Hi guys, aren't we having fun yet? Some of you that have been following my videos know that I've been trying to design a negative or an inverting buck regulator. And well, we are currently up to version 3 of my little PCB that I have designed. And I thought for myself, I couldn't get these things to work. So what I have actually found out is, so what I did was I purchased these cheap LM2596S chips on AliExpress, and it appears that they're all fake. For a start, as far as I can tell, they run at 54 kilohertz instead of 150 kilohertz, and in that tube that they sent me, the first 5 have actually failed. So I went on to look at who can sell me some genuine Texas Instrument chips, and I found out that on DigiKey and Mouser and so on, they wanted $8 to over $9 each. And on one of them there was a warning that due to chip shortage, these are in short supply or something like that. But I found some on LCSC, which is a Chinese seller, and they claim to have genuine Texas Instruments versions for $3.25 each. So I bought some at great expense. Spent $20 with shipping and everything. So when they come, I'm going to try those out and see if they will run at a genuine 150 kilohertz and all that kind of stuff. So that's what we're at. Meanwhile, I was looking at these circuits in the as described in the data sheets. So on the left over here, we actually have a standard positive voltage output, recommended circuit from the data sheet. And on the right over here, we have an inverting version. Now, if you look carefully, and ignoring this part of the circuit here, which is actually a slow startup circuit, which you may or may not put on either one of them. But as you can see, the input, positive input, is always on pin 1. It's got no pin numbers there, but that's the VIN. And the ground pin is always connected to the output. This same as here. The diode is always connected to pin 2 just before the inductor and goes to the lower output pin. And then there is a capacitor, which again is you can see over here is oriented positive at the top there. And then you have this resistor voltage divider, which then provides feedback. And on this one they're showing a little capacitor across the top one, but in my experimenting I have seen no real need to put that in, although I did put it in my original circuit, and we can certainly put it in, but it's just like a very small capacitor, 0.001 microfarad or something like that. In any case, but the point I'm making here is that the circuit is almost identical, and the only difference is that over here ground is actually connected to the lower input. Here there is no lower input because the ground is actually connected to the upper output pin, if you like, and therefore the reference is such that this voltage here becomes negative. That's the only difference. So having seen that, I'm thinking by myself, well, I should be able to, putting some jumpers on the board, I should be able to actually switch this circuit back and forth. So that is what I have done. So as you can see over here in KiCAD, I have put like a jumper on this circuit, and that's what I'm going to try. Don't know if it's going to work, but we'll find out. So we've got a jumper over here, and to the ground inputs over here, or the 0-volt input if you like. If it's negative, then we should have this pin connected, and it'll be connected to this top pin, and that actually becomes ground. And we will have the negative voltage on this output pin. If we connect pin 2 and 3 together, we are talking positive, and now the ground is connected to the lower rail over here, and this becomes ground and that becomes positive voltage. So that's what we're going to be trying out. And I've laid out the board as such. Not much. I'm actually using a power socket because these are kind of like power inputs, so they're going to have enough current capability. So I'm using a little power socket, and I'm going to make a short little piece of wire which will connect to the pins over there, so I can jumper them across here or jumper them across there. And this is the board that I had made. So you have seen me make these PCBs before, so I won't include the soldering. If you look at Buck Regulator version 1, I think you will see it. Also, how I make the little PCBs, it's pretty simple. And if you go to my channel, as you can see there, I made up a playlist here, make custom PCBs at home, and 2 parts: how to enter the circuit into KiCAD, and exposing and developing and etching and drilling. So you can have a look at that if you are interested. And for the record, again, these are the DUD LM2596s that I got, and I guess, you know, for what is it now, $3 or $4 for 40 cents each, or whatever it is, I guess you get what you pay for. And I've also bought some of these XL6009 chips, which also one wonders if they're going to be any good. I'll be checking those out as well, so keep an eye on the videos. Those things I have a different idea for, but we'll find out when we get to them. So I built up that little PCB, and it's got one of these dud chips on there which we have to remove. And I found that I purchased these solid capacitors also on AliExpress. You can recognize them because they got red on them instead of black. And these things are actually good. They do have low ESR. It actually says on there super low ESR, and it's true. These are solid aluminium capacitors. They have actually like a solid electrolyte in them, if you like, and as opposed to the old-fashioned capacitors like these guys here, they have like paper soaked in some electrolyte in there or something, and it's rolled up with aluminium foil. In any case, this is what I received from LSLC, or whatever they're called. Where are they? LCSC. They've already gone up in price, as you can see. Since I bought them, I paid $2.40 or something. Now they're $2.84. So they came in this package here with a humidity indicator and some silica gel. I wasn't aware that they are prone to be not being able to take humidity, but nevertheless. And when I got these, you won't be able to see it unless I really zoom in on these things, but they actually have a logo on there which is National Semiconductor. And I thought to myself, oh no, we don't have, because it said on the thing that there were Texas Instruments, but then I had a look. I looked at it on the internet, and apparently Texas Instruments bought National Semiconductor at some years in the past, and so therefore I guess they are, for all intents and purposes, Texas Instruments. So we're going to put this one on this board here. So the first thing we've got to do is we've got to remove, let me unplug this over here. So I made up a little plug here with some wire on it, and I can plug it in this way or that way. And if I plug it into those two pins, it'll be positive, and if I plug it into those pins, it's supposed to be negative. But we'll try that positive first, because even those ones that failed, they all seem to work up to a point. Some of them didn't work at all, what's up to a point in positive mode, but they didn't work in negative mode. They kind of blew up. Alright, so let me adjust the camera so we can have a look at that. Okay, so I'm going to do my trick with my two speed bit soldering irons. I've got these things set to 300 degrees. There we go. Now I want to add some flux. Some more light on it for me, but of course there's a bit of a glare for you guys, but I can see better that way. Just making sure that there is enough solder on there. So I'm going to put a bit of flux on the body as well. All right. Let me see if it's all lined up. Okay. I just used this iron over here and heated up that little tab there, so the body is actually stuck on now. and that should take care of the pins. Well, it's been a bit of a ride, this one. I think it's been about 6, maybe even 8 weeks before for the conception of this circuit that I designed it to actually being able to finish it. So first of all, I bought those cheap Chinese chips, and of course they failed, these guys over here, and I didn't know if it was the chips or something wrong with the circuit, so I went over it again. I've made about 3 different types of circuit boards, and this last one here I decided to add a jumper on there so I can actually run it as positive or negative. If it's 1 to 2 it's negative, and 2 to 3 it's positive. And then of course these output pins over here, pin 1 would either be ground and pin 2 will be V plus, or it'll be V minus and this pin will be ground. So I've got it currently actually hooked up as in the positive mode, and as you can see we have 12 volts coming in on the power supply here, and we have 10.6 volts coming out. And if I increase the current, 600 milliamps, 700 milliamps, 800, 900, 1 amp, because the chip on there can handle up to 3 amps, but probably you would have to have better have a heatsink of some description. And so I've actually designed this thing. I wanted to be able to produce half an amp as a negative voltage. That's what I wanted it to design it for. In any case, so it's working just fine in the positive mode. So let me switch it to the negative mode. Okay, so now it is running in negative mode. And the interesting thing about it is that it actually works as a boost converter in this mode as well. And the idea was to generate minus 12 volts from positive. So there we go. You see, I've got it set up with this load over here so that it actually thinks it's positive, because this electronic load can't handle it if it is negative. It comes up with a little error over there that says reverse voltage, and it doesn't do anything then. So, but I've got the multimeter hooked up, and as you can see at the top of the screen over here, it is actually minus 1.3 volts. And the interesting thing about it is that if I reduce the voltage, it will stay steady. It's drawing a half an amp right now. See, I'm only inputting 11 volts now, inputting 10 volts, inputting 9 volts. It just keeps it steady at 12 volts. So that's actually a good thing. It actually works as a boost circuit in this way. But in any case, I'm planning to, and even if you give it more voltage, it just stays at 12 volts. So it is working rather well. But this was the idea. I can put 12 volts in and I'll get minus 12 volts out, so that if I put this on if I'm just developing a circuit, if I put this on a PCB, maybe with an audio amplifier or something, and needs plus and minus volts, 12 volts, I can actually just give it one input voltage from, you know, one of these wall warts or something like that, and I will have the positive and the negative voltage available. So I had a bit of a battle, as I said. The chips didn't work, and then I now finally got the, as I showed before, the real chips in over here. But the this capacitor over here, the one with the red side on it, is a solid aluminium capacitor, and this is the one here that was on there, and it wasn't working, and I was getting feedback, and it wasn't regulating, and it was just terrible. And so I had to go through the circuit with the oscilloscope, and I found out that this little capacitor was a dud. It's supposed to be 100 microfarads, but it had less than 100 nanofarads. So once I replaced that, everything is working just fine. So this is another circuit that I have developed now that I can use. And but I will actually add some more output filtering to it. If I'm using this, I didn't put it on this one because the filter actually would have to be over here, and then another capacitor there, so I'd have to put a another inductor on it. But then I wouldn't want to switch it to positive mode then, because if you're in positive mode, you want to filter, the inductor has to be here and the capacitor. So but this part of the circuit is working pretty good now, so that's what we're trying to achieve. So I'll leave it at that, and if you guys want to subscribe and all that sort of stuff, I would really appreciate it. Anyway, I will see you guys later. Thanks for watching.